two types of collisions, elastic and inelastic. Most collisions are somewhere between these two extremes, but they're useful mathematical extremes. In an elastic collision, like with an electron and an electron, they're both negatively charged. The electrostatic force will mean they don't actually hit one another. They will get to 1,000th of a millimeter, and then they will whiz away. They might be going different speeds before and afterwards, but the total kinetic energy is the same. KE equals a half mv squared for this one and this one. The kinetic energy of the system, these two kinetic energies, will add up to the same before and afterwards. Kinetic energy is a scalar, not a vector, so therefore it doesn't matter if they're both got the same kinetic energy going in different directions. Where a momentum is vector, and therefore two cars can crash and go nowhere. Then the other sort of energy, elastic, plastic. Plastic collisions, just like two cars come crashing along and all the kinetic energy is gone, turned into heat energy, and also the energy that bent all the metal up. Kinetic energy gone, that's plastic. Plastics were so named because they were easy, when hot, to bend into any shape that you wanted. That's why we call this stuff plastic. It acts elastically when it's cooled down.